Given a node in binary search tree, find the next node as per in-order traversal. Let's find out how to answer this question in a technical interview. To begin with, let's cover real quick what is a binary search tree. A binary search tree is a binary tree with three main properties. The first one is the left subtree of a node contains nodes with values lesser than the node's value itself. Secondly, the right subtree of a node contains nodes with values greater than the node's value. And the last property is that the left and the right subtree each must also be a binary search tree. Next thing to know is there are three main ways to traverse a binary search tree: pre-order, in-order, and post-order traversal. In pre-order traversal, we traverse the node itself, followed by the left child and then followed by the right child. For the given tree, the pre-order traversal will look something like this. In case of post-order traversal, we traverse the left child, then the right child, and then the node itself. So for the given tree, the post-order traversal will look something like this. And lastly, for in-order traversal, we traverse the left child followed by the node itself and then the right child. So for the given tree, the in-order traversal will look something like this. So let's come back to the question. Our question is that we are given a node in a binary search tree and we have to find the successor node as per in-order traversal. So for example, if your input is node 6, then your output should be node 7. So you might be thinking, well, you can always print the whole in-order traversal for the tree and then given the specific value, you can print the next value, right? Well, the problem is that you do not have access to the root node directly. So you can't print the whole in-order traversal for the given binary search tree. You are just given a single node in a binary search tree which may or may not be the root node. However, to your advantage, this is a special binary search tree in which each node has a link to its parent node. Next, let's take a few examples of the nodes in the binary search tree so that we can come up with our algorithm. Suppose you are provided the input of node 3. Since the in-order traversal is in the form of left child followed by the node itself followed by the right child. So that means if you are given a node, its left subtree has already been traversed. The next thing to traverse will be the right subtree, and inside that right subtree we have to pick the leftmost child. The leftmost child of the right subtree for the node 3 will be node 4. So that was simple, isn't it? So if for a given input we have a right subtree, then the leftmost child of the right subtree is going to be our successor node. Next, what if the input node does not have a right subtree? Let's take the example of node 4. Since node 4 does not have a right child, we will go to its parent node. Once we reach the parent node, we can check where did we come from. Did we come from the left child or the right child? If we came from the left child, then the parent node is our answer. So in this case, we go from node 4 to node 6. And then from node 6, we check that we came from the left child, that is node 4. So node 6 will be the answer. Next, let's look at a scenario in which we reach the parent node from the right child. Suppose you are given the input of node 7. You traverse to the parent node, node 6. After reaching node 6, you realize that you came from the right child. So, in this case, you go further up, that is the parent of node 6, that is node 3. So, once you reach node 3, you again do the same check, whether you came from the left child or the right child. Now here we are again coming from the right child, since node 6 is the right child of node 3. So in that case, we go further up to the next parent, that is node 8. Again, at node 8, you will check whether you came from the left child or the right child. This time you came from the left child, since 3 is the left child of 8. Once you find a parent node such that you are reaching the parent node from the left child, you have found your answer. So in this case, node 8 will be the successor node of node 7. Lastly, let's look at one more scenario. Suppose you are provided the input node of 14. So as per our algorithm, 14 has no right subtree. So we move to its parent. We reach the parent node 10 and we realize that we came from the right child. So we move up. We move up to node 8 and again we check whether it was from left child or right child. We realize that again we are from the right child. Once we are at node 8, there is no more parent. Node 8 is the root node. So in this case, we have reached the end of the binary search tree. That means there is no other successor to node 14. Now we have an algorithm ready. Next, let's take a look at how will we code it. To begin with, let's take a look at how our node class will look like. We will have 4 properties: the link to the left child, the link to the right child, the link to the parent, and the integer value. Next, we will define our method. Let's call it getInOrderSuccessor. That method will take an input parameter of node object and it will return a node object. The first thing that I have added is a null check. I want to make sure that if the input is null, then the output is also null. Next, we will check if the input node has a right child. If yes, then return the leftmost child of the right subtree. Here is how to get the leftmost child. You will keep traversing to the left child of the given node until you reach null. And once you have found a node in which the left child is null, that means you have found the leftmost child. Next, let's go to the else condition, in which you do not have a right subtree. So in this scenario, we have defined 2 variables: the node itself, which is the input node, and then the parent node that is gonna keep track of the parent. As our first condition, we check if the parent is null. Imagine if it was root node or something. So in that case, we just want to return null back. Then we do the check that if we reached the parent node from the left node or the right node. If parent.left is equal to node, that means we have found our successor node and we can return it. Otherwise, if this condition also fails, then we will run a while loop. The while loop will keep going up the parent again and again and again until we reach a point that we have reached a parent node from the left child. Once we have found such a parent, we can return that value. If such a parent is not found ultimately, then this algorithm will automatically return null because we have that check while parent not equal to null. I will add the GitHub link to the full working solution in the video description. I will highly recommend you guys to try it on your own before looking at the solution itself. I hope you guys like this interview question. I will be adding more such interview questions to my YouTube channel, so do not forget to subscribe. Until next time, happy coding!